So while I'm still trying to figure out how to fix my camera, I still wanted to make sure you guys got your videos at home. So we're going to be doing this for a little while, hopefully not for too long. Tonight's video is in 6.1, Newton's first law. Your learning goals are all three. Describe how forces cause changes in motion, demonstrate and describe Newton's first law, and explain the meaning of net force. So some of these we've already done before the break and we're coming back to, but we'll tie everything together understanding Newton's first law. So let's start off by remembering exactly what a force is and understanding how forces change motion. Remember, a force is a push or a pull. It's some action that physically changes the motion of an object. Newton's first law will deal with forces and how they physically change the motion of objects. Newton's first law is known as the law of inertia. Inertia, that's a very important word we're going to discuss. And what it says is that an object's motion will continue, meaning an object will stay in the same motion unless some outside force, some outside net force acts on that object and changes it. So recall what net force is. I'm going to refresh you in just a moment, but net force is zero, an object stays at rest. If net force is non-zero, therefore unbalanced, its motion is going to change. Look at the diagram of the golf club hitting the golf ball. What do you notice? You can see that there's a few forces acting on it. You've got the weight of the golf ball, you've got something known as normal force, which we're going to talk about a little more in depth in class, frictional forces, and the physical force of the club acting on the ball. Remember vectors, force vectors. So first look at that question in the bottom right. According to these vectors, in what direction is the net force? Think about it for a second. It is to the right. Notice that the force of the club is the bigger arrow. Always about the bigger arrow. So we like to talk about Newton's first law in terms of net force. And the classic way it's always said is in that second bullet. An object at rest will stay at rest, and an object in motion will continue in motion at constant velocity unless there is a net force. So forces, net forces, are going to increase and decrease the speed of an object. Or they can just change the direction of an object. Remember, it doesn't matter because force is a vector, and because we deal with velocity and velocity is a vector, they are going to be related. The reason why we call Newton's first law the law of inertia is because of what inertia is. Inertia is a term that we give to this property that all matter has. It's a property in which an object wants to resist changes in motion. So objects that have more mass have what's known as a greater inertia. They want to resist changes more. So a bowling ball is going to be harder to push than a golf ball. Summing up, Newton's first law of motion, also known as the law of inertia, is an object at rest will stay at rest, and an object in motion will continue in motion with the same speed and direction unless acted on by a net force. It's important to add that net force. So an object will maintain the same speed, either not moving or constant velocity, if net force is zero. But if net force is non-zero, then you're going to have some change in either the speed or the direction. I want to finish up the video with a quick problem I'd like you to do in your notes. See if you can figure it out. A car drives along the highway at a constant velocity. That's important. Find the car's weight and the friction force. If the engine produces a force of 2,000 newtons, so to the right, between the tires and the road, and the normal force, which we'll talk about in class, but for now it's opposite of weight, is 12,000 newtons. Pause the video and give it a try. Solving this problem, first what are we looking for? The weight and frictional force on the car. What were we given? We were told normal force, the upward force, was 12,000 newtons, and the force to the right was 2,000 newtons. And the important part was the fact that it was moving at a constant velocity. Because it's constant velocity, net force is zero. Because net force is zero, that means all forces must balance. Therefore, drawing a free body diagram, we can see that up must balance down and right must balance left. Now that diagram is slightly inaccurate. That should say 2,000 right and negative 2,000 left. But you guys get the idea. Because there is no net force, because of a constant velocity, this car has all of its forces balanced out. So that's it for tonight, and I'll see you guys tomorrow in class.